Hi everyone, welcome to 5.2. Just as a heads up, we are going to split this problem or this section up into two parts. First, we're going to do the problem number 1 that you see on my screen right now, and then in the next video, we'll do problem number 2. So 5.2, falling from the sky. A rock is dropped from the top floor of a 500-foot tall building. A camera captures the distance the rock traveled in feet after each second. And I see over on the side, they've got a picture of a building. I've copied a picture of a building into my notebook as well. If you can't print out these PDFs, I understand. And you don't need to make like a detailed drawing of a building, but it might be useful to have these numbers in your notebook, both for future reference and also so you can label them and point to them while you're doing these problems. If you want to do that, go ahead, pause the video, make your notes, make your drawing, and then unpause the video when you're ready to keep going. Okay, number 1, how far will the rock have fallen after 6 seconds? Show your reasoning. So take a minute. If you've already solved this problem, keep watching. If you haven't, pause the video now. Solve this problem or answer this question on your own. How far will the rock have fallen after 6 seconds? And then once you've got an answer, tune back into this video and I will go over what I think some answers might look like to this problem. Okay, and welcome back. So for this problem, I am imagining there are 2 different answers that people might use, but both kind of involve some important things to notice about this problem in general. So let's notice those few things first. First, did you notice that the numbers in the rock were actually the same as the table from problem 5.1? Because if you didn't, you might want to take advantage of the fact that this information is actually already written in the table in the previous problem, and you can use that to your advantage. And this problem is asking what happens after 6 seconds. The first thing that you might want to think about then is how far does the rock actually fall each second? So from second 0 to second 1, the rock falls 16 feet. From second 1 to second 2, the rock falls 48 feet. And you might say, but Mr. Powey, doesn't the number say 64? Yes, but that's the total feet, right? If the rock was at 16 feet down and then jumped to 64 feet down, that's a jump of a 48-foot gap or a 48-foot fall, right? And if you're not sure, let me grab my calculator. Where's my calculator? So let me grab my calculator here. So the jump from 16 to 48. Or sorry, 16 to 64. So 64 minus 16, 48. All right, the next one goes from 64 to 144. So 144 to 64 is a jump of 80 feet. Right, so plus 80 feet. And then the next jump, let's do that, 256 minus 144 is a jump of 112. And then the last one from 400 back to 256 is a jump of 144. So maybe I'm not sure how you're going to use this yet, but these are the spreads as we go down. So remember, the question is like, what happens after 6 feet or after 6 seconds? Right, this is my question down here. And I think one answer that a lot of you might have is the first of all, you might say, well, remember, the building is only 500 feet tall. So after 6 seconds, the rock will hit the ground. Right? After 5 seconds, it's already at 400 feet, but we knew that in the last second it jumped 144, so it doesn't have that much more to go before it hits the ground. So we assume that next jump is going to go all the way down. It's going to hit the ground. It's only 500 feet. It's only a 500-foot building. Right? Remember, it's only a 500-foot building. So the rock's going to hit the ground. So why? Because the building is only 500 feet tall, and the speed of the rock is increasing. Now, what do I mean by speed of the rock? Well, the first second the rock only dropped 16 feet, but in the next second the rock dropped 48 feet, and then 80 feet, and then 112 feet, and then 144 feet, and so in the next second the rock's going to drop even farther or even faster until it hits the ground. So the second answer someone might come up with, if they didn't think about the fact that the building was 500 feet tall and they kind of got captured in on this question of like, well, how fast is the rock falling? Or what is the pattern? They might have done something a little different. They might have said, I think there's a pattern in these jumps, so let me see if I can figure out what that next amount will be. Right? They want to figure this out. And that seems like a very mathematical thing to do as well. So how are they going to do this? I think there's a lot of ways to do it. Let me show you one way to notice and take advantage of the pattern. So this involves what are called noticing the second differences. So from 16 to 48 is a jump of 32. And if you don't believe me, 48 minus 16, 32. The jump from 48 to 80 is also plus 32. Right? 48 plus 32 is 80. And notice, if I add 32 again, then I end up at the plus 112. So what we're noticing is that each time the amount the rock drops is changing in a predictable way. From 112 to 144 is plus 32 as well. So what's going to happen in this next one? From 144, we might expect there to be another plus 32. 144 plus 32 is 176. So we would guess that in the 6th second, the rock will drop an additional 176 feet. So if the rock had dropped 400 feet after 5 seconds, then 400 plus 176 is 576. So the rock will drop a total my pencil head keeps breaking. of 570. Just broke my whole pen. It's fine, I have a replacement. 576 feet because of the pattern. In the 6th second, the rock will drop an extra 176 feet. So this is the only problem I'm doing in this video. So I want you to make sure that you take a step back and are comfortable with this pattern. Because whether or not you already thought of it before you hit unpause or you're just seeing it now for the first time, I want you to realize where these 32s came from and where this 176 came from. And if you're not sure where those came from, go back and watch the video again, because that's a big deal. It's so important that I'm even going to give these 32s a name. These 32s are going to be called the second differences. Right. They are how much you're adding. They are the change of how much you're adding each time. And if you see it, right, all the second differences are the same. It's always plus 32, plus 32, plus 32. And that's not a coincidence. We're going to talk about this more in the next videos, but for right now, I'm going to end this one, and I will see you in problem number 2.